Hello, my name is Leonel Bazan, and my teammates are Fernanda Flores and Emiliano Carrillo. In this project, we will be measuring the volume of a cup in 3 different ways. The first one will be by manually measuring the cup and finding the volume. The second one is by using a Cartesian plane and using integrals. And the last one is with an online calculator that finds the volume. The purpose of this project is to apply what we have been learning in class to a real life situation, and it will help us understand the topic much better. Hello, today I'm going to measure how much is my cup. So for the top base, it is without counting the borders, it's 6.8. Let's count the bottom base, which is also 6.8, and the height will be 9.5 for the height. So I will fill this up with water and measure it in the measuring cup to see how much quantity of water can fill this cup on. So I filled up my cup with water and I'm gonna measure it here in the measuring cup. So by measuring it, it gives like 1/2 a cup, which is approximately 350 milliliters, but it could have a margin of error of 0.5.
In these steps, we graphed the cup according to the function, which is 3.4, and we have our measurements here. The length is 9.5. That's where the function came from. The width is 8 centimeters, but each of the borders is 0.6 long, 0.6 centimeters or 6 millimeters. So we subtracted 1.2 centimeters, and that gives us 6.8 centimeters in width. And we divided by 2, and that's why we have the 3.4. These are the borders for both sides. Then we have our function, which is 3.4, just a line, and it revolves up around the x-axis. And since our length is 9.5, that's our final value. So we have our volume of revolutions formula, which is p times our equation squared and the integral with the final and initial value. So then we substitute with our values, which are initial value 0, final 9.5, then our function squared. We simplify this into this one, which is the integral, and then when we substitute our final value, we get 109.82 pi, because it's multiplying. And when we plug in the 0, it gives us 0, because it's 0 times 11.656 is 0 times p is 0 again. So we subtract it and we multiply the 109.82 times p, and it gives us 345.009, or we round it to have our volume at 345 milliliters.
Hi, today I'm going to show you how to graph in an online volume calculator. First, you have to input your function here, which I already did. It's 3.4. Then you have to select your axis, which is 0 to 9.5. That is the length of the cup. You click set functions, and then you have to make sure that you're in this option. That means that it's going to revolve around the x-axis, and you click revolve, and it will show you the complete image, and it will give you your volume and surface area.
In conclusion, we learned that the two methods that were the most accurate were the ones from the math integral, the one that was done by hand, and also the online calculator. The measuring cup wasn't as accurate, and we believe that it is due to the fact that it doesn't have decimal points, and it is not as clear to see exactly where it lands, the water, the level. And from this project we learned how to measure the volume of revolutions of certain objects with these shapes, and when we need to measure them again it would be easier because now we know how to get them by hand without the need of any instrument.